Okay, here we are in the middle of an upgrade of a Heathkit most accurate clock, the GC-1000. Now I've taken the time to replace a bunch of the capacitors, especially around the power supply area on this board, and also on the receiver board and the tone decoder boards. You can see here's the tone decoder board with the new capacitors. Also, I replaced the two trim pots there with two multi-turn trim pots. It makes it much easier to adjust. Now here's the other board, the receiver board, with a couple of the electrolytic capacitors replaced. And then here's the display board with a couple of the electrolytic capacitors replaced. And I purchased all these from DigiKey. You can buy them in 1s and 2s quantity, so that was no big deal. That's a nice way to upgrade your Heathkit most accurate clock. Now the other thing that was really bothering me was how hot the power supply was getting. Now there's nothing I can do about the diodes down in there at this point. I may desolder them and lift them up to give them some more air circulation. But over here I replaced the linear regulator with a switch mode regulator. Now this regulator I also obtained from DigiKey. It's made by Murata. This is a great little 5 volt 1.5 amp switching regulator. And you can see it's so efficient it will not need a heatsink. And in order to support the test board, I just utilized a single standoff with 632 screws holding it into the place of the old heatsink. Here is the old heatsink and the old regulator. Let me see if I can zoom into that. Now this is a 7805 standard voltage regulator, and Heathkit, because they were getting too much power dissipation in this and this was getting too hot, they then fitted a resistor. Now this resistor, you can see, is 3.9 ohms at 5 watts, and it gets pretty darn warm itself. And so I have removed both those components and replaced it with this Murata switching regulator. And you can see the code there, the I50115. That code matches up with the information from Murata on their data sheet here. And you can see that the 78SR5 1.5 is the I50115H. That is the 5 volt 1.5 amp regulator. Here are some of the specs. So it can output a power of 7.5 watts, which of course is 5 volts at 1.5 amps. And there's a ripple and noise, the regulation, the normal input voltage. It can handle 24 volts. Its input range is 7 to 36. That's amazing. So this is really great. I really like this device. And it has a typical efficiency of 90%. I do not expect it to get very warm at all. Here is the DigiKey page where it was purchased, and as you can see, this unit is $4.30. There's the DigiKey part number, there's the Murata part number. Very, very nice. So here is the final installation. And let me see if I can zoom in even more. I don't know if I can or not. Yes, I can. Okay. So there the unit is in place. Left is the input, center is ground, right is output, just like a 7805 regulator. And you can see over here on the side, that yellow wire, that is where that resistor used to be, that 3.9 ohm resistor, which is not needed now with this new regulator. And you can see how the test board is now being held up by this standoff. Now the specific area that we are modifying is the voltage regulator area. And here you can see the bridge rectifier, the 4 diodes, and you can also see the 5 volt regulator with that 3.9 ohm resistor, dropping resistor. And then above that is the 8 volt regulator, which we are not going to replace. That does not have a lot of power dissipation, and it does not need to be replaced. So we've replaced U202 with that Murata switch mode supply. You can also see some of the other resistor or capacitors that I have replaced on this board. I have replaced C208, that electrolytic. I did replace C213. I replaced this large capacitor on the right, which is, and you can see them better back here. So I replaced C206 and 205. Did not replace the ceramic capacitors, they typically do not go bad. And I replaced C212, that little guy right in the center. According to the schematic, 5 volts is on one side of R207, which is a 6800 ohm resistor, and so that's where we are going to test for our proper 5 volt operation. R207 is the lower resistor right there, and you can see that's a 6800. I have taken the precaution of removing the two very delicate ICs, the ones that would be impossible to replace if something did go wrong in this modification. And I think that's a good idea for any hobbyist to do, is to remove those two ICs. Okay, here we have a digital voltmeter. We're going to measure that voltage on that pin. 4.994. That is definitely close enough for our needs to 5 volts for the logic power supply on this clock. Now I'll just put the parts back together and we'll see what happens. And check out where I'm grounding my my ground wire. It's over at the tab of the 8 volt regulator, which is a very convenient hole. I'm starting the reassembly process, and you may notice that one of these screw holes here does not really line up very well. And so I have loosened the transformer screws, and I'll loosen these other two screws that are holding the PC board down, so that hopefully the PC board will maneuver itself and kind of allow these screws to line up with the plastic bosses that are in the bottom part of the case. Okay, here's the other modification I did where I replaced those two 5K single-turn pots with multi-turn pots for the 100 Hz and 1000 Hz tone decoders. Now you may notice a couple other things. See that little tab sticking up right there? That is a ground that I installed so that it'd be easy for me to attach a scope probe to. And then those two little wires are also test points that I built in, so that you could adjust the free running oscillator frequency of these two tone decoders. And I believe even Heathkit maybe has suggested that that's a better method of adjusting the tone decoders than what's in their manual. So there's a couple of points on the tone decoders, and you can get this on the internet. And I just used my oscilloscope and probed onto that with the ground probe over here on that guy, and adjust the free running oscillator frequency to be basically 100 Hz and one's at 1000 Hz. And it sure worked well. And you can see a couple of the other capacitors that I have replaced on this board. I did replace a couple of parts that were next to this tone generator because I wanted to make sure that they were still high quality parts and not drifting due to temperature. If I replace them again, I'll probably look for some NPO capacitors if I could find one. I'd like to replace the more frequency critical components with NPO type capacitors. Here's the clock attempting to obtain lock. I plugged it in about 2 minutes ago. You can already see the data light is flashing, so it's attempting to get lock. And since I replaced the capacitors and retuned the circuit, it has been obtaining lock easily within 5 minutes, whereas before it was taking much longer. I am using an outside antenna. Okay, the clock has just obtained lock. Took about 5 minutes this time, and everything seems to be running fine. (5:03 p.m.) Let's see. can't even get down in here to touch that, but that's as cool as can be. There's no heat being generated by that switching component. Now, at this point I'm running it off of AC, but I kind of plan to operate this off of DC anyway. But in either case, that regulator is still being used. So I think it was a wise choice to go ahead and replace that. So there you have it, the upgrade to the Heathkit most accurate clock. 2 worthy upgrades that take about, maybe 3 or 4 hours to complete at a cost of less than $30. So I think it's a great upgrade.